Hello, good morning to everyone. Welcome to our basic calculus course, and the lesson for today is week 9, derivatives of trigonometric functions. So to start with, I would like to emphasize that trigonometric functions are very important functions because they relate the length and the angle associated with them. So without trigonometric functions, it will be impossible to solve many quantities. So I'm hoping that after this lesson, you will be start memorizing the derivatives of trigonometric functions. So to start with, let us discuss the derivative of the most basic trigonometric function, which is the sine function. The derivative of a sine function is sine u is equal to cosine u, then the derivative of u. So let me give you an example. For example, we have y is equal to sine of 4x. So our u here is equal to 4x. So if we get the derivative of this, which is y prime, then it is equal to cosine of 4x. Then the derivative of 4x, which is just 4. Then the final derivative, we just rewrite this one. So 4 cosine of 4x. So another example, if we have f of t, like 10 sine of, for example, pi t. So our u here is pi t. So if we get the derivative, which is of f prime t, then it is equal to, so then it's 10 cosine of pi t. And the derivative of pi t is just pi, because pi is just a constant. Then f prime t is equal to 10 pi cosine of pi t. So this is our derivative. So let me give another example which involves the chain rule. So example, y is equal to 4 sine cube, then x squared plus 1. So this involves chain rule because our sine function is raised into third power. So we can also express this like this. So 4 sine of x squared plus 1 raised to 3. So if we get the y prime of this, or the first derivative, then it will be 3 times 4, that is 12. Then sine of x squared plus 1. Because this is 3, we subtract 1, so 2. Then we get the derivative inside, so that would be cosine of x squared plus 1, and the derivative of u, which is 2x plus 0. So our final answer for the first derivative is 24x. So just multiply this and this one, and sine squared x plus 1 squared plus 1, and cosine of x squared plus 1. So I hope that made sense. The next function is cosine u. So the derivative of cosine u is equal to negative sine u, then the derivative of the angle u. For example, y is equal to cosine of 5x. So our u here is equal to 5x. Therefore, our first derivative is negative sine of 5x. Then the derivative of 5x, which is only 5. Our first derivative is simply negative 5 sine of 5x. So let us not forget that the derivative of cosine is negative sine. So there should be negative sign there. Another example, let us FT 9 cosine of x cubed. So our u here is equal to x cubed. So the first derivative f prime t is equal to 9, then negative sine of x cubed, then derivative of x cubed is 3x squared. Simplify this one. That should be negative 27 and x squared sine x cubed. Okay, so 27, negative 27 because 9 times 3 times 7, then we have a negative sign here. So that's negative 27 x squared, then just write sine x cubed. Okay. Let me also give an example of cosine involving chain rule. So y is equal to cosine raised to 4 for x plus 1. So this function can be rewritten equal to cosine for x plus 1, then raised to 4. So if we get the first derivative of this, we must do the chain rule first. So that's 4 cosine of 4x plus 1, then raised to 3. Then we get the derivative of cosine for x plus 1. So that would be negative sine of 4x plus 1. Then the derivative of 4x plus 1 is 4 plus 0 only. So to simplify that, that's equal to y prime is equal to negative 16 sine of 4x plus 1, then cosine of 4x plus 1. So this is our derivative for this example. So I'm hoping that is clear. And then for tangent u, the derivative of tangent u is equal to secant squared u, then the derivative of angle. Let me give an example. So y is equal to tangent of 9x. So y prime, therefore, is equal to secant squared 9x, then derivative of 9x, which is just 9. So y prime is equal to 9 secant squared 9x. Okay. Another example, f of x is equal to -5 tangent of let's say tangent of x. So f prime x is equal to -5 secant of secant squared x, then derivative of x is just 1. So f prime x is equal to -5, then secant squared and x. So this is a simple problem. Let us move to cotangent. So for cotangent, derivative of cotangent u is equal to negative cosecant squared u, then derivative of the angle u. Example, y is equal to cotangent of x squared. So over u here is equal to x squared. So the derivative y prime is equal to negative cosecant squared, then x squared. Then the derivative of x squared is just 2x. So y prime is equal to negative 2x. Then cosecant squared x squared. Okay. So let me give an example of cotangent with chain rule. So y is equal to 7 cotangent raised to 4 and 1 minus 2x. So y prime of, let us first express this as cotangent 1 minus 2x raised to 4. So our first derivative is, so 4 times 7, that is 28. Then cotangent 1 minus 2x raised to 3. Then derivative of cotangent is negative cosecant squared 1 minus 2x. Then derivative of 1 minus 2x is 0 minus 2. So our final answer for this one is equal to, so that is a negative, negative, and positive. So that would be 56 cotangent cube 1 minus 2x, then cosecant squared 1 minus 2x. Okay, so this is our final answer for this example. So let us move to cosecant u. Derivative of cosecant u is equal to negative cosecant u for tangent u, then derivative of u. For example, y is equal to cosecant of 10x. So y prime of this is equal to negative cosecant of 10x cotangent of 10x. Then derivative of 10x is equal to 10. So our y prime is equal to negative 10 cosecant of 10x and cotangent of 10x. So that's how it is. So trigonometric combination examples. For example, we can use a product rule that involves trigonometric combinations, like for example, uh, hold on. Y is equal to x squared, then sine of 4x plus 2. So you will notice that this is a product between u and v. So we can assign u to x squared and v as sine 4x plus 2. So if we get the first derivative, so y prime is equal to copy u, so x squared, derivative of v, so that it will be cosine of 4x plus 2. Then the derivative of 4x plus 2 is equal to 4 plus 0 plus copy v, x squared. Then the derivative, no, sorry. Copy v, so that would be sine of 4x plus 2. Then the derivative of x squared is equal to 2x. So we get a first derivative. So that would be 4x squared cosine of 4x plus 2 and plus 2x sine of 4x plus 2. Okay. So this is an example of product rule with trigonometric functions. So another is that we can have quotient rule with trigo. For example, y is equal to sine x all over sine x plus cosine x. So this is a quotient rule that involves trigonometric functions. So if we get the first derivative of this, so that would be copy v. So this is u and v all over v sine x plus cosine x. Then derivative of u, that is cosine x. One. If you would like to get the derivative of x, then minus copy u, so sine x, derivative of v. So that is cosine x plus negative sine of x all over sine x plus cosine x, then squared. So to simplify this one, so y prime is equal to maybe just write all the terms. Cosine x, sine x plus cosine x minus sine x cosine x minus sine of x all over sine of x plus cosine of x squared. So we just need to follow the quotient rule. So in most of the given items in the exam, so you will be needing to substitute a value for the angle. So please be conscious about the angle unit, because if the problem says that the angle is radians, you should put your calculator into radians. If it's degree, then you should put the calculator in degree mode. So most of the time, if your angle is in pi, therefore your angle is in radians. So if it's a little bit bigger, like 90, 60, 100, most of the time that means degree. So please be conscious about the angle unit. Then put your calculator into the right mode for that angle. So let me give an example for that. Example, y is equal to 10 sine of x squared plus 3. So first derivative is equal to 10 cosine of x squared plus 3. Then derivative of x squared plus 3 is 2x plus 0. So our first derivative here is equal to 20x cosine of x squared plus 3. So what would be the first derivative if x is equal to pi, then in radians. So therefore, we need to substitute pi here and calculate this using your calculator. So if we do this in our calculator, let us use the radians mode. Okay, so 25 cosine of 5 squared plus 3. So that is the answer is 59.96. So this is our answer. So I'm hoping that this is clear and it's making sense. So I'm hoping that you memorize all the formulas and get ready for your exams. So most of the things that I discussed here are exam related. So this will be a helpful video for you to watch all over again. And I hope to see you in the next lessons. Thank you very much. Have a good day.